Hi there. Here's my solution to question 6.85. 10,000 switches, of these 1,000 of them are bad. An inspector is randomly drawing a switch. Every switch then has the same chance of being chosen. So in part A, what's the probability that the switch you drew is bad? So I'm going to start by calling the event B, means that we have selected a bad switch. A bad switch has been chosen. So the probability of choosing a bad switch, well, there are 1,000 bad switches out of a total of 10,000 possible. There we go. So the probability that the switch is not bad, we could write that as the probability of B complement. So it's not a bad switch. Well, if 1,000 of them are bad, then 9,000 of them are not bad out of the 10,000 total. There is part A. So part B, understand the first switch was bad. So we are assuming that the first one was bad. How many switches are left? The number left then, out of the 10,000, there are 9,999 that are left. So of that, how many of those are bad? Well, I've already chosen a bad switch. We started with 1,000 bad switches, so there are 999 bad ones are left. So what's the conditional probability that if I draw a second switch, what's the conditional probability that this switch is bad? Well, the probability that my next switch is bad given that the first switch was bad. So understand, one of the bad switches is already gone. That's the condition. So there are now only 999 bad switches that are left out of a total of 9,999 switches that remain. That's your answer to part B. So for part C then, we're doing exactly the same analysis, but now we're supposing that the first switch drawn is not bad. So either way, I've drawn one of the 10,000 switches away, so there are 9,999 switches that are left. But if the first switch was not bad, that means that all 1,000 of the bad switches remain. So this changes the conditional probability. So I am drawing a second switch. What is the conditional probability that the second switch is bad? But now we're assuming that the first switch was not bad. We'll call that the complement of bad. So understand, there are still 1,000 bad switches left that could be selected, but one of the good switches is gone, so that means instead of a denominator of 10,000, the denominator is down by 1. It's 9,999. So in this context, the idea of the condition, whether the switch was bad or whether the switch was not bad, either way the denominator is down by 1 from 10,000 to 9,999 because we've selected one of the switches. That condition, though, also could affect the numerator. So since in part B we selected a bad switch, there were only 999 left. That could be the second of the bad switches. In part C, the first switch selected was not a bad switch. So when I selected the second switch, how many of them remained that were bad? There were still all 1,000 that remained that were bad. The bottom line here is when you write conditional probabilities, it can affect what the numerator and what the denominator look like.